Building test automation without a structural foundation leads to maintenance-heavy scripts that destabilize and break as your project grows. To prevent this, we are going to transform a blank project into a 2026 industry-standard Playwright and TypeScript framework. You only need two tools: Visual Studio Code and Node.js version 18 or higher. Investing in this architecture now creates a system that remains manageable even when your test suite reaches hundreds of files. We start by opening the terminal and initializing the latest Playwright project, selecting TypeScript as our default language. The installer generates a basic set of files, but these are just the starting point. For an enterprise-level project, we need a more modular approach. This diagram shows the four-branch directory structure we will build. First, the tests folder contains specific test scenarios, while pages houses application logic. Utils holds shared helpers, and test data stores JSON files. Data and logic never mix. Next, we update the tsconfig.json file. By configuring our path maples here, Playwright can handle our TypeScript code directly without extra compilation steps. This separation of concerns transforms a single script into a professional testing ecosystem. The page object model acts as a bridge. It ensures that your test scripts never interact with the UI elements directly. We implement this by creating a new class, loginpage.ts, inside our pages directory. Inside the constructor, we initialize the Playwright page fixture, allowing the class methods to interact with the browser session. We avoid CSS selectors. They often change during UI updates. XPath selectors are similarly fragile, relying on exact HTML order. Instead, we use semantic locators. We use getByRole to find elements based on accessible names, which is exactly how a user actually identifies a button or a link. For cases where accessibility tags aren't present, we use getByTestID. This provides a stable anchor that developers can maintain specifically for testing. We keep these locators stored inside the POM class methods, away from the actual test flow. This means if a locator changes, you only update it in this single class file, and every test that uses it will be fixed instantly. Now we author the test case in our tests directory, importing the new login page class. We pass the built-in Playwright page fixture into our test function as a parameter. In older frameworks, you might have used hard-coded sleep timers to wait for elements to load. This creates slow, unreliable tests. Here is Playwright's auto-waiting in action. The test pauses just long enough for the element to become visible and stable before it continues. We run the test command and we see our validation pass in the terminal. For more detailed analysis, we open the trace viewer. This provides a full diagnostic timeline of every click and network request. This allows you to find the source of a failure without needing to manually rerun the script and hope the error repeats. Dynamic auto-waiting and detailed traceability remove the guesswork from debugging your automation. This modular structure allows you to scale. You can add hundreds of test cases without ever increasing the complexity of your core logic. Demonstrating this level of separation is a common requirement in interviews for senior automation roles, as it shows you can build for long-term maintenance. Your next milestones are integrating API mocking for faster execution and connecting to CI/CD pipelines for automated builds. Mastering this blueprint aligns your workflow with the technical standards of 2026 and provides a foundation for any complex